Usually when we think about the people who fundamentally changed our understanding of the universe, we picture these, figures of immense power.
Right, or at least people with the perfect tools for the job.
Exactly. But I want you to picture this for a second. A man is born in the late 1500s, and a brutal bout of childhood smallpox leaves him with crippled hands.
Oh, wow.
Yeah, and permanently weakened, blurry vision.
I mean, that is not exactly the physical resume you'd expect for an observational astronomer.
No, not at all.
Yeah.
You would think this guy would struggle just to read a book, let alone map the stars. Yet this exact same man, with his crippled hands and bad eyes, becomes the father of modern optics.
Yeah.
He improves the telescope. He becomes the very first person in human history to figure out exactly how the planets move.
Which is just staggering.
Right. Oh, and right in the middle of revolutionizing modern physics, he has to take a break to successfully defend his own mother from being burned at the stake as a witch.
It is honestly a life of staggering contradictions. Like, it's a messy, chaotic, earthly life set against this obsessive quest for heavenly perfection.
It really is. And so today we are taking a deep dive into the historical sources to uncover the epic, tragedy-laced, and profoundly human story of Johannes Kepler.
Yeah, this is a fun one.
Our mission today is to show you why Kepler isn't just, a dusty name in a high school physics textbook. He is the ultimate bridge between the ancient world of mysticism and the modern world of science.
Right, because this is a man who cast horoscopes for a living.
Oh, yeah.
He believed the Earth literally had a soul. Yet he laid the rigorous mathematical foundation that Isaac Newton would later use to build the theory of universal gravitation.
Which is wild. So to understand how Johannes Kepler changed the universe, we really have to look at the incredibly limited, chaotic world he started from.
For sure.
He was born in 1571 in the Holy Roman Empire into a family that was, well, essentially broke.
Very broke. His father was a mercenary who actually abandoned the family when Kepler was just 5 years old.
And he eventually died in the 80 Years' War, right?
Yeah. And his mother, Katharina, she was an innkeeper's daughter. She worked as a healer and an herbalist.
And physically, the deck was really stacked against him. I mean, he was a premature baby, constantly sick, and of course ravaged by that smallpox infection.
Right.
But mentally, he was a prodigy.
Oh, absolutely. As a kid, he would just hang around his grandfather's inn, completely amazing, weary travelers with his phenomenal mathematical faculty.
Just doing complex calculations in his head for fun.
Exactly. But for a bright, poor kid in Protestant Württemberg at the time, there was really only one path forward, and that was the church.
Right.
So he goes to the University of Tübingen to become a Lutheran pastor.
But it doesn't work out.
No, he is ultimately denied ordination. He basically can't become a minister because of his unorthodox theological beliefs.
Specifically, he couldn't fully bring himself to agree with the formula of Concord, which was the strict Lutheran statement of faith.
Right. So instead of giving him a pulpit, the church essentially sends him into exile.
Yeah.
They ship him off to Graz in Austria to be a humble math teacher at a seminary school, which had to feel like a massive demotion.
Oh, it must have been crushing. But Graz is actually where everything changes.
Yeah, it is.
In 1595, Kepler is teaching a class. He's just drawing geometric shapes on the chalkboard, and he suddenly thinks he sees the secret architecture of the universe.
It's such a great moment.
This becomes his first major book, the Mysterium Cosmographicum, and the theory is just wild.
It really is. So at the time, there were 6 known planets, right? Mercury, Venus, Earth, Mars, Jupiter, and Saturn.
Okay.
Kepler realized that in geometry, there are exactly 5 Platonic solids.
And those are?
They're perfect regular 3D shapes.
Yeah.
Like a cube, a pyramid-like tetrahedron, an octahedron, and so on. So you have 5 perfect shapes.
Okay.
And 6 planets.
And he looks at that math and thinks, this is not a coincidence.
Exactly. He hypothesizes that the orbits of the planets are dictated by these 5 Platonic solids nested inside one another.
Separated by invisible spheres. Wait, this is almost comical, though. Is he basically trying to fit the entire universe into a giant set of cosmic Russian nesting dolls?
That is pretty much it.
Like, you have a sphere, then a cube inside it, then another sphere, then a pyramid inside that?
That is exactly what he envisioned.
Yeah.
And he genuinely believed he had hacked into the mind of God. He thought he had discovered the Creator's literal geometric blueprint for the cosmos.
But, I mean, we know today that our solar system absolutely does not look like a set of cosmic nesting dolls. The theory is completely physically wrong.
Oh, 100% wrong. What's fascinating here is why it captured his imagination. and really the imagination of his contemporaries.
Because it was mathematically beautiful.
Exactly. Kepler was deeply fundamentally religious. His core belief was that God created the world according to an intelligible plan,
Right.
and that human beings were created in God's image specifically so that we could share in his thoughts through reason.
Yo, wow. So to a young, devout Kepler, this mathematical elegance wasn't just a neat trick. It was proof of divine order.
Right. But there is a fatal flaw in his nesting dolls.
The math doesn't perfectly match the sky.
Nope. His geometric shapes were just a tiny bit off when compared to where the planets actually appeared to the human eye. So to prove his theory, he needed better data.
He needed the absolute most accurate astronomical observations in the world.
And in the late 1500s, only one man had that data.
Which brings us to one of the greatest pairings of opposites in the history of science.
Right around this time, Kepler gets expelled from Graz because of the Catholic Counter-Reformation.
Because all Protestants were ordered to leave.
Exactly.
Yeah.
So in 1600, he flees to Prague, essentially as a refugee, to work with a man named Tycho Brahe.
Now we have to contrast these two for a second.
It's night and day.
Tycho is a nobleman. He's fabulously wealthy, notoriously secretive, and he runs the most advanced astronomical observatory on Earth.
Yeah.
Meanwhile, Kepler is a poor, mathematically brilliant theorist who is basically begging Tycho for access to his star charts.
And Tycho was highly protective. He gave Kepler just enough data to keep him working. He assigned him the incredibly frustrating task of figuring out the orbit of Mars.
Basically, busy work.
Yeah, Tycho didn't want Kepler stealing his thunder. He just wanted Kepler to do the grunt work. But then, in 1601, Tycho Brahe unexpectedly dies.
I noticed in the historical records that for centuries there was this massive popular myth.
Oh, the murder theory.
Yes, even a book published in 2004 suggesting Kepler murdered Tycho with mercury poisoning to steal his star charts.
I mean, it's a great true crime theory, right? But a modern exhumation of Tycho's body in 2010 completely busted the myth.
Wait, they dug him up?
Yeah, they tested his bones and hair. There was no lethal mercury. He likely died of a mundane bladder ailment.
Ah, okay.
But the outcome of his death is what changes history. With Tycho gone, Kepler inherits his job as the imperial mathematician.
And more importantly, he inherits all of Tycho's fiercely guarded data.
Exactly. Now Kepler has the numbers, and he locks onto Mars.
He tries to fit Tycho's precise observations of Mars into perfect circles, or like combinations of circles, which had been the absolute dogma of astronomy since Aristotle.
Right.
He tries 40 different mathematical models. He tries an egg-shaped ovoid orbit, and nothing works perfectly.
There's always this tiny discrepancy, just 8 arc minutes of a degree in the sky.
And to put that in perspective for you listening, that is a fraction of the width of your pinky finger held at arm's length.
It's tiny. Most astronomers of his day would have just chalked that up to observation error, blamed the telescope, and called it a day.
But Kepler couldn't do that.
No, because he trusted Tycho's data too much. And he believed God wouldn't make a sloppy universe. If the data said there was an 8 arc minute error, the model was wrong.
Wow.
That tiny discrepancy forces Kepler to do the unthinkable. He abandons perfect circles entirely. He realizes the orbit of Mars and all planets actually is an ellipse.
It's like a flattened circle.
Yeah, with the sun sitting not at the dead center, but off to one side at a focal point.
Yeah.
And this becomes his first law of planetary motion.
And he doesn't stop there. He also notices that planets don't move at a constant speed.
Yeah.
Like when Mars gets closer to the sun in its elliptical orbit, it speeds up. When it swings further away, it slows down.
He figures out the exact mathematical ratio for this, which becomes his second law. He publishes all of this in his 1609 book, Astronomia Nova.
But we should talk about the underlying mechanism here. Why is throwing away the perfect circle such a monumental shift for humanity?
Because for 2,000 years, everyone believed the heavens were a realm of divine perfection, and perfection meant uniform, circular motion.
Right.
By killing the perfect circle, Kepler shattered that barrier. But his true genius was introducing actual physics into astronomy.
Wait, what were they using before? Were people genuinely assuming angels were pushing the planets around?
Literally, yes. Angels or invisible crystalline spheres that mechanically cranked around the Earth like clockwork.
That is wild.
Kepler looked at his elliptical data and realized something profound. The planets were changing speed based on their distance from the sun.
Yeah.
That meant the sun wasn't just a lamp lighting the solar system. It was the engine driving it.
Oh, I see.
He proposed there was a physical force. He actually likened it to magnetism emanating from the sun,
Yeah.
physically pushing the planets along their orbits. He transformed astronomy from a purely geometrical exercise into a branch of universal mathematical physics.
It is a stunning triumph of reason. But just as Kepler is unlocking the absolute harmonious secrets of the heavens, his earthly life descends into absolute, unimaginable chaos.
The contrast is horrifying. He moves to Linz in Austria, and the dark years begin. The 30 Years' War breaks out, which is one of the most destructive religious conflicts in European history.
Yeah.
His first wife, Barbara, dies of Hungarian spotted fever. Several of his children from both his first and second marriages die in infancy or early childhood.
It's just tragedy after tragedy.
And he is even excommunicated by his own Lutheran church because he refused to conform to their strict doctrines regarding communion.
I saw in the notes that his mother was accused of witchcraft, too. I mean, how does the leading scientist in the world deal with a medieval witch trial?
It starts in 1615. He receives a letter that his elderly mother, Katharina, has been accused of witchcraft in their hometown. And the dark irony is that the rumors against his mother were partially sparked by Kepler's own writings.
Wait, what?
Yeah, he had written an early draft of a story where the narrator's mother consults a demon to learn about space travel.
Oh, no.
People in his hometown read a leaked manuscript, looked at his real-life herbalist mother, and put two and two together in the worst possible way.
So his own sci-fi story puts his mother in the crosshairs.
Yes, and it is a terrifying situation.
Yeah.
Katharina is imprisoned for 14 months.
Yeah.
She is actually shown the physical instruments of torture by the authorities to try and force a confession out of her.
That is awful.
Kepler literally pauses his groundbreaking scientific career. He leaves his home, moves his entire family, and spends years writing highly technical, logical legal dispatches, personally defending her in court. He meticulously dismantles the witnesses' testimonies and ultimately saves her from torture, securing her release in 1621.
Just imagine being Johannes Kepler. Your children are dying. Your country is tearing itself apart in a brutal religious war. Your mother is in chains, accused of dark magic, and you are essentially a refugee.
Yeah.
What do you do with that grief? You write a book called Harmonia Mundi, The Harmony of the World, published in 1619.
Right.
And in this book, amidst all this death and horror, he tries to literally align the planetary orbits with musical notes. He is trying to map the actual music of the spheres.
He was analyzing the velocities of the planets as they moved faster and slower in their ellipses, and he was assigning them specific musical pitches.
Like the notes on a scale.
Yes. He believed that the harmony of the universe resulted from the tones made by the heavenly bodies.
So he is mathematically writing sheet music for the solar system.
Exactly.
But the crazy part is, he supposedly discovers his third law of planetary motion in this same book. How does a bedrock formula of physics come from a search for cosmic choir music?
It comes from his relentless search for patterns. While trying to figure out how the planets harmonize, he realizes a profound mathematical relationship.
Okay, lay it on me.
The square of a planet's orbital period is proportional to the cube of its mean distance from the sun.
Okay, we definitely need to translate that for the listener. What does squaring the orbital period and cubing the distance actually mean for how the solar system operates?
In plain English, it means that the further away a planet is from the sun, the more sluggishly it moves along its track.
Got it.
Jupiter takes vastly longer to orbit the sun than Earth does, not just because its track is wider, but because Jupiter is physically moving slower through space.
So Kepler's math proved that the physical push from the sun gets weaker the further out you go.
It's a mathematically flawless law, and Kepler found it while searching for cosmic choral arrangements.
That shows us something profound about his mind. His mystical pursuits, his belief in a mathematically singing universe designed by God, directly fueled his hard scientific discoveries.
Yeah, the mysticism wasn't a distraction from the science, it was the engine that drove it.
Exactly. His ability to visualize the unseen, to imagine forces stretching across empty space, allowed him to see things centuries ahead of his peers.
Which brings us perfectly to the incredible story of his science fiction, his theory on the ocean's tides, and a massive feud with Galileo.
Oh, I love a historical feud. Let's start with that sci-fi manuscript that got his mom in trouble.
Right.
It was called Somnium, or The Dream. It was published posthumously, and it is widely considered the very first science fiction novel in human history.
Yeah.
Why did he write it?
Well, he imagined a trip to the moon, but it wasn't just for entertainment. It was a Trojan horse for physics.
Oh, so.
The actual science of a moving Earth Copernican heliocentrism was too terrifying or complex for the average person to grasp. People thought, well, if the Earth is moving, why don't I feel it? Kepler used fiction to show his readers what a non-geocentric universe would actually look like from another perspective. He realized that if you are standing on the moon looking back at Earth, the Earth appears to be the thing moving.
Oh, that's brilliant.
He used a fictional story to help humanity visualize a terrifying new reality.
And his obsession with the moon didn't stop at fiction. I mean, anyone who lives near the ocean knows the tides are linked to the moon. Kepler theorized exactly that. He wrote that the moon's gravitational pull reaches out across empty space and physically pulls the waters of the Earth, causing the tides.
Which, as we know today, is entirely correct.
But the irony here is amazing. We all know Galileo is the great champion of cold, hard science and reason, right?
Yeah.
But Galileo actively mocked Kepler's theory of the tides. Galileo dismissed the idea of the moon's invisible pull as occult mysticism.
He really did.
He literally called it puerilities, which means childish nonsense.
This is such a crucial moment in the history of science. Galileo rejected the correct answer because, to his strictly mechanical mind, invisible forces pulling across empty space sounded like magic.
It sounded too astrological.
Exactly. It sounded like action at a distance astrology. Galileo wanted purely mechanical explanations, like things physically bumping into other things.
But Kepler, who openly embraced astrology, who believed the Earth had an active soul that responded to the stars, was perfectly comfortable with invisible connections.
Exactly. His willingness to entertain the mystical allowed him to conceptualize mutual gravitational attraction. He grasped a massive physical truth about our universe that the strictly rational Galileo completely missed, simply because Galileo's mind was closed to the bizarre.
Kepler's polymath mind was open to everything. He didn't just study the stars either. He founded modern optics. How does an astronomer fundamentally change biology?
Well, ironically, because of his poor vision, he needed to understand how light worked to trust his astronomical observations. He mapped out how light refracts through lenses, and in doing so, he was the first person to explain how the human eye actually works.
Like the mechanics of it.
Yeah, how the lens of the eye projects images upside down and then vote it onto the retina, and then the brain flips it right side up.
And he accidentally paved the way for calculus just by ordering a drink.
Oh, the wine barrel story.
Yeah. He literally bought some wine for his house, and he noticed the merchant measuring the volume of this curved wooden barrel simply by sticking a straight rod through the bunghole. Kepler got curious about how you could accurately calculate the volume of a curved shape.
Right, because he realized you couldn't just use basic geometry, so he conceptualized a mental trick. He imagined slicing the curved barrel into thousands of flat, infinitely thin layers.
Okay.
If you calculate the area of those flat layers and stack them back up, you get the volume of the curve.
Wow.
That concept, breaking a curve into infinitely small, flat pieces, is the fundamental building block of integral calculus.
He even looked at a snowflake falling on his coat, wondered why it was always a six-sided hexagon, and posed a geometric theory about the most efficient way to pack spheres together.
Yeah, the Kepler conjecture.
Right, and it was so complex that it wasn't formally proven by mathematicians until 2017.
Which is insane.
From the vastness of Jupiter's orbit to the microscopic structure of a snowflake, he saw geometry and divine order in absolutely everything.
He did. But, every earthly story has an ending, and Kepler's is remarkably poignant. We reach 1630. Kepler is 58 years old. He has finally published his Rudolphine tables.
Which was a massive, comprehensive catalog of planetary data.
Right. It would be the gold standard for astronomers for decades. But despite his fame, he is essentially broke. The imperial treasury owes him a massive amount of back pay.
So he travels to Regensburg to try and collect his salary. But he falls ill with a fever and he dies just weeks later.
And the final indignity is that he was buried in a Protestant churchyard, but shortly after, the graveyard was completely destroyed during the chaos of the 30 Years' War.
Oh.
His physical grave, his bones, were entirely lost to history.
He leaves no monument of stone, yet his legacy is the modern world. His 3 laws of planetary motion became the exact foundation that Isaac Newton used to build the theory of universal gravitation.
Yeah.
Newton famously said he stood on the shoulders of giants, and Johannes Kepler was the giant holding him up.
Looking back at his life, you see that Kepler lived in an era where there was no clear line between astronomy and astrology, or between physics and theology.
Right.
He shows us that human progress doesn't always come from purely cold, robotic, step-by-step logic. It comes from passionate curiosity.
Yeah, and sometimes that curiosity starts with flawed, mystical ideas, like nesting Platonic solids.
Exactly. But if you have the rigor and the honesty to test those wild ideas against the actual data, you can uncover the truth.
And I think that honesty is what makes him so relevant to us today, because in his masterpiece, Astronomia Nova, Kepler didn't just publish his final correct answer for the elliptical orbit of Mars.
He actually published all 40 of his failed mathematical attempts, too.
Right. He wanted the reader to see his struggles, his dead ends, the agonizing process of getting it wrong over and over again before finally getting it right.
He left his work radically transparent, highlighting the messy, frustrating human effort required to decode the universe.
We live in a world obsessed with curated perfection. You know, polished feeds, flawless presentations, and scientific conclusions presented as sudden, clean strokes of genius.
Yeah, that's not how it works.
Not at all. Think back to that sickly kid with the smallpox scars and the crippled hands who changed the universe precisely because he refused to ignore the messy data. So what might we gain in our own lives and in our society if we were as radically transparent about our failures and our struggles as Johannes Kepler was?